All right, before we start looking at Python functions, let's think about algebra for a little bit, to go back to like Algebra 1. So we're all used to functions like, equations like this, where f of x is equal to maybe 2/3 x plus 5. And if I were to ask you, well, what's f of 2? Right? I think we don't know what to do in this situation. And we could even pick a different equation, like let's say I had g of x comma y is equal to 3 times x plus y, maybe all over 2. And I said, what's g of -1 comma 4? I think we don't know what to do here as well, right? But rather than work out the algebra here, let's move on over to idle and see how this would look as Python code. So now I'm on the computer, and what I want to do is take these algebra functions and turn them into Python code. So I've got a demo program here, it's blank, and I'm going to go ahead and open this thing up in Python. And, well, it's blank. And so the first thing that we're going to do is we need to declare a function. We'll just do this top one first. And so the way you do that is you define a function. And I'm just going to use the same name I did over here. I'll call it f, so it looks like algebra. And the argument that gets the information or the argument that gets passed in is going to be some value of x. And so when we want to evaluate it, I might say y equals. And so now I just have to translate that expression into Python code. And we can't do fraction bars. But what I can do is 2/3. And then I can say times x plus 5. And order of operations is actually going to work right here, but I think it's kind of, sometimes I like some parentheses for clarity, and now it really looks like I have the fraction 2/3. And so this will calculate the value, and now we need to send the value back, okay? So, and this won't make sense until actually you see me use the function. So, I'm going to write return y. And the return statement is that this is going to be the final value that the function is going to produce. So if we wanted to test this out, what I could do is I could say something like y1, and I'll show you how you can test it a bunch of times, equals f of, well, in this case, in this example, I use 2. And we could print y1, and we'll see what happens here. So when I run this window a little smaller. All right, so when I run this, what happened is this code here does not get executed at first. It's just a definition of how something will work. So the very first line of code that gets executed is this one right here that's not indented. And so this takes the number 2 and it sends it up into the x function. And this expression here got evaluated. And so 2 got plugged in to this 2/3 x plus 5, and that got assigned to the value y. And then finally the y got returned. So whatever gets returned, this evaluates to whatever the return statement is, and that number got stored in y1. So in this line, 6.33 got stored in y1, and then we can print it out to verify that it worked. And so why would we use a function here? Well, one of the reasons is with functions is that you get to use them again. So let's suppose I had more homework problems expecting me to use that same formula. Well, I could say y2 equals f of -1 and print y2, and we can run it, and you can see that I got it for a different value. Now, this function right here, the g of xy, it's real similar, only this one takes 2 arguments, and you can probably guess how you could code it. So if I said g, and usually I do my function definitions up at the top, and then we'll do all the function calls at the bottom. So I'll do def g, and I'll say x comma y. So this is the input to the function, and then we'll do the math. And how about z equals, I need another variable because x and y are being used. And got to translate this to Python code. So that's, so we start out with 3 times x plus y divided by 2. And remember, when I run this, okay, we'll get an error here. Actually, I didn't try to do it, but I didn't make a call to G yet. So if I did Z1 equals G -1 comma 4, you'll see this is where we get an error, and it says the int is not callable, and it's, oh yeah, that's right. Multiplication is not implicit when you have a number up against parentheses, so we need to actually put the times sign there, and so we can, and so we can do this a couple times. Z2 equals G of 5 comma 18, Z3 equals G of 4 comma -8, and I can just print Z1 Z2 and Z3. And so since I've coded this function once, I can make as many function calls as I want and quickly have that expression get evaluated. So let's check and see if this works. Let's see. Oops. Random negative there. Try it again. Oh, and okay, so good. I'm glad I made an error here. So this evaluates to whatever the expression returns. And if you'll notice something, I forgot to return a value, and that's where I got the none, right? So we'll just pretend I made that mistake on purpose. So I'm going to return Z, and now when I run it, I get the expression evaluated each time. So that's good for now, and in the next video, we'll take a look at some functions from geometry instead of just ones you're familiar with from algebra.